Welcome everyone to this first inaugural Arctic Tslip webinar on Valentine's Day in 2025. And today we have our team. We're going to present here and share different parts of the project with you or describe it. And so it's me, Anna Livjedal with Woodwell Climate Research Center. I'm here in Homer. I'm a permafrost hydrologist, and I enjoy leading big teams of projects in the science world. And then we have Hig from Ground Truth Alaska, and Christine from International Arctic Research Center at University of Alaska Fairbanks, and Erin, she's with the native village of Eyak, and Bex and Willow, who are with the Chugach Regional Resources Commission, Kate and Caleb, who are having the Wellspring Group Consulting, and Sierra Fletcher for Nuka Research as well. So that's us who are in the sort of the management team, and then of course Arctic Tslip team at large includes everyone here. So Arctic Tslip, it stands for Arctic Tsunamigenic Slope Instabilities Partnership. And yeah, so I'm a water and ice scientist, and we've got Bex, the climate program coordinator. Hig is the earth science expert in landslides, and he's a geologist. And Kate and Caleb, they're both evaluators, and they're also helping us, guiding us in the co-design process in the project. And then we have Erin, she's an environmental coordinator, and Christine, she's a communication scientist. And then, of course, all of you as well. And today's presentation will first start with a big picture overview, and then a science overview by Hig. And Kate and Caleb are going to talk about the co-design approach, because together we can do great things. And Christine, Erin, and Bex are going to talk about the community engagement, and then Christine will close us up with communication and how to get involved. And then we have some questions and discussion. So in Alaska, we are not short of natural hazards, and same goes for many areas across the Arctic. We got tsunamis, earthquake-induced tsunamis, avalanches, big weather, fires, earthquakes, volcanoes, sea ice, and coastal erosion and permafrost thaw. And then we got landslides and landslide-generated tsunamis. And for those, at least not in Alaska, we don't have monitoring system for, because we have a lot more to do to learn and understand these hazards. So that's where Arctic Tslip comes in. So our overall Arctic Tslip mission is to foster connections among a diverse group of people that are all interested in landslides and landslide-generated tsunami hazards, and to generate a shared understanding of this hazard in cryosphere-affected regions, so where we have permafrost and glaciers, and also to facilitate collaboration to identify and frame research needs so that we together can build a foundation for future projects and actionable solutions. And more specifically, we are right now funded for the next 2 years from NSF in a planning project. And I also want to add that Arctic Tslip formed back in 2020. So there has been a group conversing since then. And this is sort of the phase 2, I'd say, of Arctic Tslip, where we now have $200,000 from NSF to facilitate project planning here. Because our goal by the end of 2026 is to submit a nested group of research proposals to the NSF Office of Polar Programs on landslides and landslide-generated tsunami hazards. So our first mission is to identify these research needs. So what research do we need to do to support hazard assessment and management, both from the local scale and also up to the national level, and even international, what we can do and learn from each other. And the second is to coordinate these research ideas and the resources that we have access to, and then find project leads to lead respective research proposal and to build the teams around these different research proposals. So that is our closest, most upcoming goal here, end of 2026. And of course, Arctic Tslip, the vision of it, the mission of it goes beyond this NSF proposal submission. But that is as a first start. So let's jump into the science background. So Hig, I'm going to stop share and you can grab the screen.
Thank you. I'll jump in here. Let's see. So yeah, I'm going to try to tackle this basic motivation question. I mean, we have a limited amount of time on this Earth. Is this what we want to spend our time on? Do we want to spend our time studying this very kind of obscure hazard? It's not all landslides. It is these deep-seated landslides that are the largest ones. And I think it would be reasonable to look at, Alaska's history and say, well, I don't know, these don't seem too important. We've had other disasters, but these have been kind of an obscure corner of our complicated landscape. We've actually spent a lot of energy on various different geologic hazards, earthquakes, tsunamis, volcanoes. There's a really great ongoing effort looking at landslides and specifically focused on shallow landslides, so ones that involve soil and trees. It's still developing, but in a way it'd be understandable to spend most of our effort on that because we've seen a dozen people die from these landslides in the last decade, much less impact from deep-seated landslides. So in trying to understand this myself, I've been looking around the state, doing some mapping of different large deep-seated landslides like this. And in particular, focusing on a subset of these. These are the ones that are most active. The red dots are ones that are moving pretty quickly for a slow landslide, so they might move 10 feet a year. The black dots are catastrophic landslides, so far faster than that, like you couldn't outrun them sort of speeds. And they're all large and recent, so this is since 2012, and they're all over 1 million cubic meters. Now, one of the ways that I think about this is, the concern is that one of these things might intersect one of our communities, some of our infrastructure, and really impact us in severe ways. Alaska is blessed with a lot of really remote country, so if that hazard was substantial, then we would get some warning shots, right? We would get some of these events happening in remote places where there's not really a big problem, but we get to see how they play out. So I'm going to show you a couple of warning shots that we have had recently. One is along in these mountains, the Brabazon Mountains near the Alsek River, which is off to the right. And there's a slow landslide right here that's been moving over the last century. This arcuate kind of shadow you see here is this cliff up at the top of a landslide like this. During a big rainstorm in August of 2021, it failed. It slid down the mountain, banked off the far side of the valley, and swept all the way down. Most of the landslide is right here. And those little ponds that were there formed a tsunami that flattened the forest over this big area. So what looked like a pretty innocent little corner of the wilderness suddenly became very exciting. Here's a really different sort of warning shot. No catastrophic landslide here, but if you focus your eye in on this area, you'll see a large section of this mountain start moving kind of off in this direction. And it's moving pretty fast. So that's interesting in and of itself. But what I want to emphasize here is that the first several years of this animation, we don't really see any motion at all. So we happen, even though we only have these satellite images for the last decade and a half or so, that happened to catch the beginning of this. And this is not the exception. We see things beginning in many of our mountains in Alaska. And if we look instead at landslide-generated tsunamis specifically, and I've kind of narrowed these down to ones that are in areas of glacial retreat, there have been a tremendous number of these recently, and it seems that they're actually quite uncommon going further back in time. So it seems like they're becoming more common. We have every reason to think that this might have something to do with climate change. Climate change is driving extreme rain. It's the #1 risk for large landslides. Glacier retreat can remove the support from the bottom of some slopes and then they might fail. Permafrost is sometimes an important part of the strength of mountain slopes. And so as we warm it up, as we thought, we can have landslides there. One way, I sometimes use this Venn diagram to try to think about different hazards and what might be going on here. And you can kind of think of some that might be these disasters that have particularly catastrophic impacts, things like the 1964 earthquake or the recent pandemic. You can think about the wildfires in LA. There are also disasters that, while they are very high impact for the people directly involved, our society has plenty of capacity to deal with them, but they also happen really frequently. So we have to think about those a lot too, home fires, car crashes and such. Now, a Venn diagram, of course, invites you to think about what's in this intersection. And I think you'll find it's a little difficult to come up with examples where there are events that are both so frequent that we see them happen all the time, and so consequential that they really change the course of history, that our society struggles to respond to them. And I think that's because when things happen a lot, we adapt to them. We move them out of this high consequence area. And this works really well as long as nothing changes. And of course, right now we are dealing with an ongoing change. We're dealing with these climate-linked disasters that I think in some cases are starting to fall into that intersection, especially floods and wildfires and landslides as well, is at least what I'm suggesting here. So I showed you a few of these warning shot remote landslides. Are there places where these landslides could potentially impact places where our infrastructure, where our communities are? So this is Portage Glacier, and if you look at the mountain off to the right, you see all these cracks in the bedrock here. So this is the sort of thing that we see with slow landslides, and sometimes slow landslides can suddenly fail, like that example I showed earlier. In this case, we've done some preliminary modeling. This is work by Pat Lynette. It's kind of a mid-range case. This is sped up. It spans about 2 minutes, and it shows a possible wave from a landslide here spreading down Portage Lake. Now, one of the concerns here is that there's a visitor center right on the shore here. It's very popular. There's a lot going on there. We also have a tremendous amount of infrastructure, road, rail, fiber optic internet, power lines, all this stuff that's in this area of potential impact. This is not an isolated case. There are other places where the same sort of vulnerability exists. This large slow landslide, where we see it subsided up here and bulging out here, is above Eklutna Lake, a hydropower lake. The village of Eklutna is downstream, tons of infrastructure down there. So we have a really serious concern here. If you start letting yourself be a little creative, you can come up with all kinds of bad things that might happen. And my thought is they may be higher probability than we would like. This is maybe a rather hyperbolic possibility. This is a picture I took from the beach looking at Mount Fair. If this were to fail, it potentially could hit the North Pacific and produce a tsunami that might impact the coastlines all around the Pacific. There are other much more localized questions. So these polygons here are all large landslides. The red ones are particularly active out on Nelson Island in Western Alaska. And there are a number of villages nearby that could be impacted by an event here. One of the ones that worries me the most as far as economic impact, much more than loss of life, is the area up by Adigan Pass. There's one landslide that's been studied quite a bit here down at Frozen Debris Lobe A, but it turns out there's this big cluster of landslides right near Adigan Pass. So the Dalton Highway runs through here, but this is also where the Trans-Alaska Pipeline is. So this is like half of Alaska's economy. This animation shows a landslide developing over here. And there's actually a crack that opens up in this area right there. So far, no problem, but we're really close to the road, and the possibility seems to be that we could see something that would impact this area. So that's an argument that maybe these are urgent problems for us, for our communities, for our economy as Alaskans. And I will say, I've been very Alaska focused here. I do care about other places too. This just happens to be what I know the most about, and I think our work will apply in other places. But I wanted to kind of look at this whole set of questions from a different angle and sort of think about the academic science and how it is that we approach these questions as scientists. This opinion piece is an interesting one. It points out what is a sort of incongruous lack of study of landslides despite their really high impact. And in this opinion piece argues that maybe it's because scientists find the subject boring. So I'm going to try to argue it's not so boring. There are a tremendous number of things we could do with being more synoptic, taking a larger perspective, looking at large collections of these events in order to try to understand what's going on. I definitely won't go into details of what I'm showing here, just trying to give you a sense that there is these statistical approaches that I think actually could be quite fruitful. Looking more on a very narrow physical science question, this is a big landslide that happened at Askja caldera in Iceland. The landslide, and it's a seismic record of that landslide. The landslide is this big blotch of color over here. And one thing that's very strange about this is the kind of noise that this landslide produced before it failed. So it was moving along slowly, and these bright lines, these are kind of like changing tones emanating from the landslide. We don't have a good explanation for what creates those. There's also this kind of bluish bit here just before. Although this landslide was making lots of noise for a day leading up to its failure, for 2 minutes before failure, it got really quiet. We don't know why. If this was one-off, then that'd be one thing, but we actually see this pattern repeated in other places. It might be that to understand this, we need to take some of the tacks that tectonic geologists, people studying earthquakes, take, where they try to understand how the crushed rock in a fault zone responds to different forces. And this is something that's been a really vexing problem for earthquake geologists. They've figured some things out. We may be able to apply those for landslides, or maybe by studying landslides, we can help out the earthquake geologists. There are huge questions around how these landslides generate tsunamis when they hit the water. At some level, it makes sense. Yeah, it hits the water, it's going to make some sort of wave. But when we actually try to model this, there's quite a wide range of results, and we have trouble explaining some events like this one that happened in August, where a relatively small landslide produced a surprisingly large tsunami. And I want to, as my last bit here, just spend a little bit of time on permafrost, because I think we have particularly large gaps in our understanding of the role of permafrost in these. So this is a very standard way of kind of picturing the temperature of the ground as you go down. Like if you drilled a hole down into the earth and measured temperature along it, what you'd see is that up at the top, the temperature varied a lot through the year just because of the changes in air temperature. And when you got down to 50 feet or so of depth, these would converge and be pretty stable, and that would warm steadily as you went deeper. And we've measured this sort of thing, and we've also measured that this is changing as the surface warms. It's one of the earliest really strong signs of systematic climate warming. And we can imagine that down the road, this could continue to change, and this will dramatically alter the state of permafrost. Now, this model is very simple, and it does a good job of explaining some landslides, retrogressive thaw slumps, active layer detachments, but there are other phenomena that it doesn't explain very well. This is going to be a before and after, but I'll show the after first just because it kind of emphasizes how weird a mystery this is. This is a huge pile of gravel sitting out in the middle of a swamp in Alaska. And look at this and think, how on earth could that have gotten there? Well, some locals took a picture much closer to when this whole story started. There was a huge landslide in February 2013, and this one boulder escaped from that landslide and slid down the slope and kind of mowed down the forest as it went and stopped out in the marsh. Now, when this boulder sat for a little while, warmed up, and thawed, it crumbled into gravel. So we can see that this material, the strength of it was actually due to permafrost, that's what was holding it together. And when it thawed out, it crumbled into gravel. Now, this landslides that are happening down below the permafrost that would actually have big chunks of permafrost in them, that's not really predicted by that simple borehole kind of picture that I gave before. We also see these sudden accelerations of big masses. This particular valley, if you watch in this area, you'll see it move. This is an area that models suggest permafrost should be really stable, but yet we're seeing this tremendous activity up there. It's possible that we need to draw on science from ice sheet dynamics, where they see signs, or they postulate anyway, that friction from motion is actually heating ice up and causing that ice to be weaker with time all the way. I'll show this study, which is a lab experiment, where on the left they did an experiment looking at soil creeping without permafrost, and on the right they did it with permafrost. And the thing that's really surprising is the one with permafrost has this shear band. It has this section that broke and moved quite a bit down at the bottom. That seems like it really contradicts my expectations that permafrost would make things stronger. Instead, it's showing a case where permafrost makes things weaker. I'll stop there. I really appreciate your time. I'm excited to be working with all of you on this stuff.
Okay, we're going to move over to Kate and Caleb. So you guys grab the screen, Kate and Caleb, and share.
Yeah, thanks, Hig, for the overview of the science for everybody. So I wanted to talk about how do we go about confronting an issue that has so much complexity? One way that we can look at this is a process of co-design. Co-design is an approach that seeks to actively involve all project collaborators, so scientists, citizens, agencies, end users, in the design, implementation, and evaluation processes of a project. So the aim here is to ensure that projects and solutions are inclusive, effective, and centered on the needs of those who will use those solutions. So this requires investments in resources and relationships, putting people most affected by an issue in a position to co-design a way forward to address that issue.
Caleb, could you receive this as a portion of your screen? So if you make it into slide presentation mode, maybe increase so we can see the entire slide over the whole
view. I think Kate's on that.
Perfect.
Yeah, just maximize and I think you can play it too. So in co-design, there's a high degree of substantive collaboration. So the power of co-design aims to build trust in people and processes. It embraces more diverse ways to think about and address an issue. And it moves away from traditional ways of involving people that have been lackluster at best and harmful at worst. Our hope is that a co-design approach honors and supports multiple knowledge systems and leads to outcomes that are both practical and meaningful. So why co-design? Let's go through some of these elements. Co-design is not the same thing as consultation. It's not community-based participatory research. We're not adding and stirring voices to a pre-existing project. The process in co-design is as important as what we produce. And what we produce in this case is deciding what research topics are important to us. For us, co-design is a way to build shared ownership over a process and product. We're all invested in this together. It acknowledges and supports different ways of knowing. There isn't one way of knowing, there are many. Co-design requires power sharing. This means that decision-making authority is distributed amongst everyone involved in the project. And it must utilize more transparent information sharing processes. Clear communication is vital to success, and all participants need access to the information needed to make meaningful contributions. We also look at utility. This process is meant to generate utility, developing insights and solutions that are timely and well suited to the specific communities and contexts they are meant to serve. Good co-design also respects existing frameworks for decision making, such as tribal councils, city councils, borough assemblies, and other decision making spaces. integrating new perspectives without discarding valuable structures that are already in place. And in this process, we're constantly challenging our assumptions about needs and gaps and how to address them, pushing us to rethink and refine our approaches collaboratively. So I'm going to pass it off to Kate. She's going to discuss a bit about what the co-design process looks like for this project and some of the principles that help guide this work.
Okay, thank you. So there are many models of co-design that exist in the world. In this project, we are utilizing the specific framework of co-design called Authentic Co-Design, developed in Australia by Max Hardy and Anthony Boxall. In this process, there are a total of 6 steps and 5 principles that guide the work. And in this specific project, we are going to be focusing mainly on the first 3 steps, but all of the principles. So I'm just going to walk you through what that looks like. So just keep in mind as we look at these, this process, that it's iterative, and we keep coming back to some of these earlier steps along the way. But we start in a space of readiness. And when we talk about readiness, we're aiming to ensure that all participants understand the purpose of co-design, have the necessary resources, and are prepared to engage meaningfully. It involves identifying key participants, setting expectations, and establishing a supportive environment for collaboration. It's a step that requires asking, what priorities should we address together? And what would success look like? In other words, are we ready to jump into this process? Shared understanding is a step that is about getting clear on what problems we are confronting, the co-design process itself, and the context in which we're operating. When we talk about scope, this step is defining the boundaries of this project, clarifying what can realistically be achieved within the given time, resources, and constraints. A well-developed project scope is one that all parties can agree on, or can agree is worth addressing. And this step often happens simultaneously or in quick succession to building a shared understanding. A well-developed scope is one that accounts for a variety of different interests, invites critical thinking and creativity, and recognizes boundaries and constraints. The benefit of developing the scope together is that it strengthens relationships. Although this is often one of the most challenging aspects of co-design, reaching agreement on the scope will build the capability to collaborate on a bigger co-design project when we talk about solutions. And in future phases, the process will involve co-designing what was agreed and implementing agreed actions. Broadly, co-designing what was agreed means refining the project scope and constructing various solutions to the problem that was identified. And when we get into implementing what was agreed, this just means putting plans into action. And I just want to make a note about review, the review step. This is one place in our project where we differ from the original model, and that is that we infuse evaluation and feedback into the process along the way and not just at the end. This is important to us because we want to know where adaptations are needed in our approaches, because as I hope we've been making clear, the process is as important as what we are producing. So we mentioned principles, co-design principles. There are 5 of them that guide our work. The first is be substantial. Co-design has to go beyond being just symbolic participation. All participants have a meaningful role in shaping the work, not just offering input at select moments. A substantial co-design process ensures that contributions are valued and influence the direction of the work. Be collaborative and intentional. All input is appreciated, expertise is acknowledged, and specific use of input is respected. Being collaborative is not just about agreeing to solutions or actions, it's about co-creating the processes as well. Participants should be able to see how their contributions influence decisions. Foster mutual learning. The diversity of knowledge systems and participant backgrounds are an inherent strength for this project. Taking a collaborative approach to the construction of the project scope, Decision-making spaces and processes shows a commitment to mutual learning. This may mean including views that are different from yours, having distinct or opposing points of view or sets of information, and still being able to engage in a productive process. We all are learning from each other. Be open and transparent. Transparency means operating in a way that ensures that it is easy for others to see what actions are being taken and how these actions and decisions have been informed. It involves communicating and working authentically with everyone, sharing data, information, and knowledge by default, unless there are external reasons not to, like legal or confidential requirements, in which case it's just a practice of being open about the reason for not sharing that. And be aware of overlapping systems of government. Decision-making spaces often overlap across tribal, municipal, state, and federal levels, making it essential to navigate and engage with these different authorities to create effective and inclusive solutions. This requires meeting people where they are, recognizing communication styles, decision-making processes, and cultural or institutional norms, so that information is shared in ways that are accessible, relevant, and aligned with how they operate and engage. So I just want to reiterate at the end of this slide and this part of the presentation that we are not co-designing solutions in this phase of the project, but we are designing research processes that are responsive to community needs. Solutions are a part of the co-design process, but we're not there yet. We're working together now in a process to identify what further information is most needed to take action on. We are together designing the approach of how to better understand landslides and landslide generated tsunamis here in Alaska. And with that, I'm going to pass it to Erin.
Awesome. Thanks, Kate. Good morning, everyone. My name's Erin Hsu. I'm the environmental coordinator with the native village of Eyak. And I just wanted to give a little bit of background as to, why as a community and a community-based tribe, we see value in this project and why we think that this is a really valuable approach for us to participate in. So as Higgs said, this is an urgent issue and people and infrastructure could be at risk from these events. Landslide and tsunami risk should be considered in emergency management and other planning efforts where it's appropriate. We really think that early involvement in the research process, especially at the early stages of formulating research questions, can help make the science more actionable and useful for decision makers, emergency responders, and people living and working in these places that might be impacted. By having a say in what questions are asked during the research, those most at risk from these events can help shape the direction and the dialogue of research in ways that will be relevant and applicable to local needs. And also, quite frankly, working with local partners makes research go a lot more smoothly. Community members often have unique, specialized knowledge about local conditions. For example, we may be able to help confirm or raise awareness about local slope deformities or other geophysical hazards, identify new risks based on traditional knowledge or personal observation, or point out connections between data and lived experiences that can help contextualize study results. Furthermore, operating in many of these areas is really complex. Local communities can help assist with fieldwork logistics or even fill in gaps in research coverage through partnerships and collaboration. And this slide has a couple of pictures from some of NVE's camp mobilization for our summer fish camp, just to give an example of how complex some of that can be. And finally, research creates jobs in local communities. From NVE's perspective, we'd like to engage with the broader research community to help bring these jobs to our community and to our tribal members. We might not have in-house expertise on geophysics, but we do have expertise on the local environment and geography. We employ several general scientists and biologists. We operate internships to assist our youth with work experience, and we have a labor pool of tribal members that we can draw from with various skills and interests. Partnering with researchers on projects like this allows us to build capacity in the sciences and employ more people locally to protect NVE's traditional territories, and possibly connect some of our talented youth with researchers and scientists that they can learn from. So that's kind of why Cordova and Native Village of Eyak is interested in engaging with this co-design research process. So I'm going to hand it over to Bex to tell us a little bit about what this engagement looks like.
Yes, hello. So our engagement strategy. We are looking to get as many community decision makers, well, anyone interested really, so the general public as well, involved from the start. And over the past year, we've been talking to people in different communities about their needs and their interests, and we plan to continue doing that this year. We're open to conversations about what the community is interested in, and like what they want to know about what's happening with the land, and would love to continue working with them to identify what research questions would be the most impactful for their region and what their concerns really are, and how to address those in our final research proposal. So we currently do have funding to visit up to 7 communities and hold workshops in person, but we're happy to work with any community, even if we don't hold a physical workshop there. So before each visit, we will work with local leaders to figure out what topics matter most to that community and then tailor the workshop presentations based on that feedback of their concerns and questions. During the visit, we'll also plan to arrange one-on-one meetings with community leaders directly to discuss the project and their goals for research, and kind of lay the baseline of how involved they want to be or not be if the proposal is successful. We also plan to hold public presentations and workshops for everyone that's interested to learn more about the project and to share their thoughts. So direct communication straight from the community. Long-term, our 2026 plan is to host a gathering with all Tslip participants, and we do have funding to cover up to 2 people from each visited community to join and help shape that draft research proposal in person. This will be key in creating that $20 million research proposal, and our hope is for the communities to stay connected long-term as partners going forward. So why is it so important to put community voices at the center? Kristen will explain our communication strategy and how we plan to use it to create meaningful research.
All right, thanks, Bex. I'm gonna actually share my screen. Oh, looks like I can't do that, so never mind. Oh, there we go. All right, well, I want to start off by just talking very briefly about how I define communication, because I think it's really critical to how we're thinking about our communication plan in the context of this work. So there are many different definitions out there, but I like to think of communication as the relational process of generating shared meaning. And what that actually means, if we break down that definition, is that communication is relational. It involves more than one. It's a process, so there's some back and forth between those people who are communicating with each other, and it is done with the goal of generating shared meaning. So it's not enough to just be communicating outward and hoping that your message is relayed the way that you had intended. The idea behind communication is that we want to create some shared understanding with who we're communicating with. And that's super important because it shows us as scientists and as a project team that our communication has to really be audience centered. It's our job to do a good job researching and understanding and connecting with the audiences that we're trying to serve through this work. And why do we care about communication in the Arctic Tslip project? Well, we all communicate, so it's very easy to take communication for granted or to just assume that it's happening. But when we actually design communication more intentionally, it can help us more strategically direct our resources in ways that help us meet our goals. And we have some very specific goals in this project to meet. In addition, when we're thinking about this context of landslide generated tsunamis and other hazards, effective communication of the science, of the risks, helps build understanding, enable collaboration, and facilitate community response. And so we have 5 main objectives for our communication in this project. And so our first one is to broaden participation. And so in addition to engaging physical scientists, we want to engage a wide variety of experts, including managers, policymakers, community representatives, scientists of all disciplines, and international collaborators. We also want to facilitate collaboration. So if we're thinking about the Tslip as a network, we want to add additional people to this network. We want to strengthen connections across the network. And we also want to help people discover each other so that they can build teams of different kinds of expertise that can work together. We also want to raise awareness. So although the main focus of this project is not doing a large communication effort focused specifically on the science, we know that it's important for people to understand the state of the science as well as future research efforts and be part of shaping those efforts. We also want to foster relationships. One of the goals of a planning grant is to help people communicate with each other and make those connections. And so we want to increase trust and mutual respect between people of different backgrounds. And then finally, we want to identify priorities which reflect community concerns and scientific gaps, as this can be part of our path forward in determining research projects to address under the large project support. And so there are several ways that you can get connected to Tslip. So you can join the Tslip network. We have an email list. There are future webinars. There's a newsletter coming soon. And we're also in the process of rebooting the Arctic Tslip website, where you can get information about what's happening with the project. And so you can use that QR code to join the network. I'll also put the link into the chat here as we move into discussion. And then we have another webinar coming up soon. So on February 28th at 10 o'clock a.m. Alaska time, we'll have a panel with USGS and the State of Alaska Division of Geological and Geophysical Survey, where we'll hear how Arctic Tslip can complement and expand on ongoing efforts by DGGS and USGS on landslide and landslide generated tsunami hazards in Alaska. So this will be another great webinar. You definitely won't want to miss this. So just to summarize the whole presentation today, so deep-seated landslides are growing and little understood risk. And as you've learned today, we're using a co-design approach because it embraces diverse perspectives, builds trust, and can lead to more sustainable outcomes. In other words, we can do great things when we work together. We really value the community place-based expertise that comes to the table, and this can help identify research needs to inform local planning and action. And then we really want to emphasize that there are multiple ways to get involved, that Arctic Tslip is for everyone who's interested in discussing this hazard and working on this hazard, learning more about it, being involved in research. So please share this with others who might be interested in joining the Tslip, Arctic Tslip project. So we're going to move on now to discussion and questions. So if you have questions, I think it would probably work best to use the hand button, just since we can't see everybody's face at one time. So use the hand button if you have questions. And then we'd also love to hear from you. So in the chat, if you could please share whether there are some topics you're interested in for future webinars. Similarly, are you interested in presenting a future webinar? If so, pop your name, pop the topic in the chat. Maybe you know of somebody else who would be a really excellent webinar presenter. You can share that information in there as well. And then please use the thumbs up emoji if you agree with the topic suggestions being provided to help give us some additional information about what topics are most of interest to you all. And so with that, I think we'll move into our time for questions and discussion.